atoms again. So, we need to define atom really quick here. An atom is simply the smallest particle of an element. So an atom, the smallest particle of an element. So of course, I hope you're kind of seeing the pattern here. Scientists want to really understand something deeply. They want to know as much as they can about these physical things that make up our reality. And so what we talk about next, and you see this in your notes here, is we're asking this question, so if elements which make up matter are made up of atoms, what is an atom, or what does it look like? So that's where we're at here. It says, so what does an atom look like? So let me read this little blurb to you. Atoms are so small that we cannot see one by itself. Instead, scientists create models to help them represent what they cannot see directly. These models must include all of the information the scientists know. So, your blank should be models. That's in the sentences surrounding it. So, if you don't know how to spell it, look at that. Okay, what we're going to talk about, if scientists create models to describe this thing which is so small that you can't even see it in a microscope, what are these models and what do they look like? So we're going to take like a little kind of like tour through how scientists developed what we think of as models, or what we know to be models, because it's changed quite a bit. So the first person we are going to talk about is this guy named Dalton, and you'll see him right here. Okay, it says Dalton's theory and model, and there's also a little box because you're going to draw Dalton's model there. So this is Dalton's model. It's very advanced, and I say that sarcastically, but if you think about, the fact that it was in the 1800s and you couldn't see these things, the fact that anybody created a model of it was even pretty impressive. So in that box that you guys have on your notes, what I would say you should do, draw a little circle. Because that's what Dalton thought an atom was. Like this ball right here. He says, hey, Democritus says that atoms can't be divided. So this is something, this can't be divided. This is something so small it can't be divided. I think it's like a little round ball. So, now we've got some blanks to fill in. Hopefully it didn't take you too long to draw your circle. So, atoms cannot be divided. It's our first blank. Atoms cannot be divided. Let's go to the next statement that Dalton used. So keep in mind when we do a model, when somebody creates a model, they're taking information that they know and they're putting it into one way of representing information. So we said atoms cannot be divided. He knew that, so he made this. This isn't made of smaller pieces, it's just one thing. It's not made of smaller pieces. The next one down, this is something he had to take into account when he made this. Atoms of the same element are identical and have the same mass. Atoms of different elements have a different mass. So you have two words to fill in there. I'm going to repeat that statement, so make sure you get the blanks here. Atoms of the same element are identical and have the same mass. Atoms of different elements have a different mass. And one of the last things that Dalton had to take into consideration when he created his model was that atoms cannot change into different elements and only get recombined when going through a chemical change. So atoms cannot change into different elements and only get recombined when going through a chemical change. When it says like only getting recombined, you can almost think of that as we've got the whole Y group in here. We move your seats around. We have, in a way, sort of mimicked a chemical change. We still have all of the same people or all the same elements in here, but when we move you around in a different order, you've become recombined. So now you're chemically combined in a different way and you have different characteristics. So, that's Dalton's model. Those are some of the things that Dalton found out and that helped him create his model. So the next one, we have Thomson's model. Thomson came around a little bit later in the 1800s, and Thomson's model kind of came as a result of him thinking or finding out, not just thinking, like having this idea, but finding out through experiments that there's these negative charges that are found in atoms. Now, one of the things, it's not written for Dalton, but they knew that atoms were electrically neutral. So they weren't positive and they weren't negative, they were neutral. So since Dalton said, hey, there's all these like little negative particles going that are in this atom, he knew there also had to be enough positive particles to balance it out. So what we have here, it kind of looks like we've got the ball that Dalton had, but now we have this ball, and we're saying this ball is positively charged, and so I've got 6 little pluses to represent those positive charges. But now we've got these little yellow dots in here that have negative charges. Kind of like how you've got a muffin that has blueberries in it. Okay, the muffin is the positive charge, the blueberries are the negative charge. Overall, they all balance each other out, it's neutral. This is Thomson's model. So what you're going to want to do in this box right here is in that square, draw a circle, draw some pluses on it, and however many pluses you draw that many circles with negatives in them. So, now we get to come to the fill in the blank part. Atoms are made of even smaller parts. Thomson was the first one to say that these atoms that we say they're indivisible, they're made of even smaller things. They're made of, oh, whoops, now I'm getting ahead of myself. So, atoms are made of even smaller parts. Next line. Atoms contain negatively charged particles. And hopefully you remember this from last class, but negatively charged particles are now called electrons. So atoms contain negatively charged particles, now called electrons. The last line, atoms have a positively charged ball with negative charges scattered throughout. Atoms have a positively charged ball with negative charges scattered throughout. So again, at Thomson's is when we start seeing scientists look at atoms as even being made of even smaller parts. And that gets to be important because now we learn about Rutherford. And sometimes when I doodle on paper, I doodle little scientific things. I like to draw mitochondria from cells, and I also like to draw atoms. And when I draw atoms, I like to draw them like this. This is Rutherford's model. You probably have seen this or something similar to it. Okay, so here's the deal with Rutherford. Let's see. Rutherford performed this gold foil experiment to discover the nucleus of the atom. So I'm going to repeat that because that's your first line. He performed the gold foil experiment to discover the nucleus. And basically what he did in that experiment was he took, some atoms and he put them in the middle, and then he had all these gold foil, like kind of surrounding it. He shot some charged particles at those atoms, and depending on the way that they scattered, he was able to look at the way they scattered and predict, okay, there must be some small little core at the center of this atom. So that's why you see such a big shift, going from just a giant circle here to all of those positive charges being clumped in at the middle. So anyways, So we've got all these positive charges clumped in at the middle, but we still know that